Bismillah ar-Rahman ar-Rahim. Well, students, we have now to start off with the exercise at the end after finishing the last topic of ultrasonics. So I hope you can do this. These MCQs, and I expect you to try them. And if you find difficulty, please feel free to call me and remove any kind of ambiguity that you may be having. So MCQs I expect you to do yourself and give me some feedback. When you give me a call, I'll be able to understand. The review questions. Now the first review question is 11.1, which talks about the necessary conditions for production of sound. That, of course, you know it, that we have talked about it, and I have told you the three conditions that were very much necessary. One was the vibrating body, the second was material medium, third, of course, was the receiver. But these two conditions, vibrating body and material medium, are a must for production of sound, and sound will be produced if these two are there, whether the air is there or not. The second question was effect of medium on, what is the effect of medium on the speed of sound? In which medium sound travels faster, air, solid or liquid? And justify your answer. The second question, the speed of sound in any medium actually depends upon this formula. Speed is equal to elasticity of the medium over density of the medium under root. And of course, in solids the speed of sound is maximum because the molecules are very closely packed to each other. Now I have given a little answer also. There will be change in the speed of sound in different media. Sound travels faster in solids because the molecule closely packed. Just light, and I expect you to please delve into this problem, think about it, and try to understand it. I've given you a formula also for thinking more about it. 11.3, how can you prove the mechanical nature of sound by a simple experiment? The mechanical nature of sound by a simple experiment. This is there. We did the experiment in which we took on page 21 of the textbook. Please go over this. Explains that the mechanical nature is necessary when we took the bell and jar experiment. 11.4 says, what do you understand by longitudinal waves? Of course, this is there in the textbook, and I expect you to do it yourself. 11.5, sound is a form of energy. List three reasons. Sound is a form of energy because sound is a form of wave. Sound is a form of age. And this question is 11.5. Now, if sound is a wave, then of course it carries energy, because every wave carries energy, and sound also carries energy. And you have heard whether when there's a big bomb blast, the sound can just demolish the buildings. So sound carries energy. Second, it follows the phenomena of reflection, diffraction, diffraction, interference. So sound is a form of energy. 11.6, we know that waves manifest phenomena of reflection, refraction, diffraction. Does sound also manifest these characteristics? Yes, of course it does. 11.7, what is the difference between loudness and intensity of sound? Yeah, I expect you to see the textbook and find it for yourself and make good notes of it. 11.8, on what factors does the loudness of sound depends? 11.8, on what factors the loudness of sound depends? Of course, this is there in your textbook, and just to revise it, it depends upon amplitude. The more the amplitude, the more the loudness, on the area vibrating body, on the distance of the vibrating body from the listener, and the physical conditions of the person trying to listen to it. 11.9, what do you mean by the term intensity of sound? Name and define units of intensity of sound. Please see textbooks. And question number 11.11, what is the difference between frequency and pitch? Describe their relationship graphically. And 11.11 frequency and pitch. Please see textbook and find the answer. It's on page number 23. Describe the effect of change in amplitude on loudness and the effect of change in frequency on pitch of sound. This of course is there. 11.12. This of course is the textbook. Large amplitude means loudness is more and greater frequency means greater pitch. 11.13. If the pitch of sound is increased, what are the changes in the following? The frequency increases, the wavelength decreases, the velocity increases, and the amplitude, of course there is no change in that. So 11.13, I've written it there. Frequency increases, wavelength decreases, velocity increases, amplitude remains not changed. 11.14, if we clap or speak in front of a building while standing at a particular distance, we rehear our sound after some time. Can you explain how this happens? Of course, I'll expect you to look at page number 26. What is the audible frequency range for human ear? This of course is there. We did yesterday from 20 Hz to 20,000 Hz. Does this range vary? Of course it varies. 11.16. Explain that sound, the noise, or nuisance. Please refer to page 28-29. Describe the importance of acoustic protection. Please refer to page 29-30. And what are the uses of ultrasound? Please refer to page 31. Now we come over to the conceptual questions. Why two tin cans with a string attached between them could be better way of communication than merely shouting through the air? So, you know, the sound waves travel faster in solids as compared to gases. So when you have connected them, the two tin cans with a string, then when the sound is transferred through the solid material, so it is easier. But when you shout, you are shouting in the air, which has less velocity. 11.2, we can recognize persons speaking with the same loudness from their voice. How is it possible? It's possible because of the 11 point. It is possible because the quality of sound that determines the quality of the human ears. You know, it determines. It is one of the qualities of human. You can listen to your friend round a corner, but you cannot watch him. Yes, you can listen because of the phenomenon of diffraction. 11.14. Why must the volume of a stereo in a room with wall-to-wall carpet be tuned higher than in a room with wooden floor? Because absorption is more where there is wall-to-wall carpeting, and it is less if it is a wooden. So you have to increase the volume. 11.5. A student says that the two terms speed and frequency of the wave refer to the same thing. What is your response? 11.5. Of course, there are different things, and look at the textbook. Speed depends upon the distance and time over time. Frequency depends upon the number of vibrations per second. It has different units, meters per second. It has units of the hertz. And then this does not depend upon the medium. Frequency does not depend upon medium. Speed, whereas, depends upon the medium. Three main things. Two people are listening to the same music at the same distance. They disagree on its loudness. Explain how could this happen? This happens because each human has got its own physical conditions, and because of those physical conditions, one can hear it louder, the other can hear it less. 11.7. Is there any difference between echo and reflection of sound? Is there any difference? Yes, 11.7. Yes, there is difference because reflection can take place at any distance. You know, I can talk over here from here, and the reflection can take place at 17 meters, at 20 meters, at 30 meters. But echo can only take place if the time lapse between the sound incident upon the other medium and coming back, that distance is 17 meters, and the time lapse is 0.1 second. Echo will only occur then, but reflection can occur all the time. Yes, reflection can take place at any distance, but echo can be heard only after 0.1 second and the distance 17 meters. 11.8. Why two separate 50 dB sounds together constitute 100 dB? Explain. You know, 250 decibel sound If they are coherent source, then of course it is 100, but if they are not coherent, then it is not 100 decibels. 11.9. Why ultrasound is useful in medicines? Because they carry more energy and the frequency is more. Now we come to the numerical problems. For the first one, you will use the formula. A normal conversation involves sound intensity of 3 into 10 raised to the power minus 6 watts per meter square. What is the decibel level for this? Please use this formula. L minus L naught is 10 log I over I naught. 11.2. Again you have to use this formula. 11.3. Use the formula velocity is equal to lambda f and solve it. If you have difficulties, please refer back to me. 11.4. A doctor counts 72 heartbeats in 1 minute. Calculate the frequency. Use this formula. Frequency is number of heartbeats over time taken. And then use formula T is equal to 1 over f. 11.5. A marine survey ship sends a sound wave straight to the seabed. Please use this formula S over Vt, and to find the depth use S over 2, and the distance taken and coming back. That is the echo, so half of that is the depth of it. For 11.6, please use this formula S is equal to Vt and H is equal to S over 2. 11.7. A ship sends off ultrasound that returns from the seabed and is detected after 3.42 seconds. If the speed of ultrasound through seawater is 1531 meters per second, what is the distance? Please use this formula. S is equal to Vt, and then half of that, of course, is the depth. 11.8. The highest frequency sound humans can hear is 20,000 hertz. What is the wavelength of sound? Please use this formula. Lambda is equal to V over f, and frequency 1, lambda 1, lambda 2, and frequency 1 is 20 hertz, frequency 2 is 20,000 hertz and 20 hertz. 11.9. A sound wave has a frequency of 2 hertz in a wave. Please use this formula. V is equal to lambda f and S is equal to Vt. With this, we have finished chapter 2. After you have done this one, you have written out your notes and you refer back to me for your difficulties. I'll be in a position to judge you, and then we will do some more questions regarding this chapter. Thank you very much. Till then, please complete your homework, and for any difficulty, please refer back to me. Thank you.